Hello everyone. So today we are going to solve another LeetCode problem, which is word search. So let's first understand the problem statement. Given an m cross n grid of characters, which is board, and a string word, and we need to return true if the word exists in the grid. And the constraint is this: the word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. So we need to make sure that these words are either horizontally connected or connected vertically. And the letter cells may not be used more than once. And we can only use one cell once. So we cannot use the same cell twice to form the word. So let's understand this by an example. Let's say we have this word, right? And we have this metric. Now we need to find if we can form this word in this matrix, right? So first we will look for A, right? Because we want to form this word. So yeah, we found this word. Now we need to find B. So since the question mentions that we can only look for the words either horizontally or vertically connected, right? Since we found A, we need to find the words which are connected, and what character we are looking for, it is V. So we need to check either horizontally or vertically, right? So if you see, we don't have anything on up or below, but on the right side we have V. So we found B. Now we need to find C. Again we will do the same thing. B, check up, down, and we cannot go left, right? Because we already selected this cell. So then we check on the right side. So we have C, right? Now we again look for another C. So again we will check horizontally and vertically. Now this is not C, we cannot use it. There is nothing up. And then when we check the cell below, we found C, right? So we selected. Now we need to find E, right? So again we check right, left, and we cannot go up, right? Because the cell above has already been used, right? And we can only use the cell once. So when we check the cell below, we find E is present. Now we need to find D. Again we do the same thing. We check right, left, up and down, right? So on the left side we find D. So that means if you see this path, we found our word. So in this case we return true. Now let's look at the idea. How can we actually solve this problem? So if you see, we picked the target character from word, right? And then we try to search it in the matrix, right? And when we found it, then our target character changed to the next character of the word, and we started exploring the adjacent cells of the previous character, which was this cell, right? So we explored up, down, left and right. So we found B, then our target character changed from B to C, and then we started exploring adjacent cells of B. So we found C here, but we cannot use this character, this cell, because it was already used for A, right? So the idea here is that we'll do some kind of DFS to actually solve this problem. But another constraint is that we can only use a single cell once, so we cannot use the same cell twice to build our word. So to achieve that, we will use the concept of backtracking. So let's see how can we actually write the code for this. So first we'll take the size of the board, then we will take, if n is not 0, then we will take the columns, right? Now we have the matrix. What else do we want? So we will have to do some kind of DFS like we discussed, right? And it will be right, and we will iterate over the matrix first. Now if the current character, also we need to, if the current character, now if the current character, which is, what is the current character, it's I, bold I and j, is equals to the first character of the word. That means this character is matching, so we can actually, I mean this code is not full, this code is not complete, so, and we will do the DFS if we find the first character, first matching character. So what we'll do is we'll pass I, j, and what's the target character in the word that we are looking for? The first index, because the 0th index matched, right? So along with this, what we will have to pass, x by position to be matched, right? Now we will check if position to be matched has reached the word dot size, then we return true. Otherwise, now here we will use the concept of backtracking. First we will save the character from the board, so we'll call it a backup and x and y, and then we'll replace it with something which is not present in our string, contains only lowercase and uppercase. So we'll replace this character with something different, so that this is not picked up again when we do the DFS. And now we build the direction array, how -1 0 1 0 -1, and then we iterate over the array of directions, and we explore the adjacent cells, explore the adjacent cells of this, of the current cell, right? So what will be next x, it will be x plus direction of d, and what will be next by here, right? Now first we need to check, is cell valid, which is we need to check if x, this x and this y are valid, and we also need to check whether the word in this position, so let's copy paste it, is matching the word in next x and next y. If it's matching, then we'll do the DFS again, right? So first let's create the, so what we need here, int a, int b, and what we return if a is greater than equal to 0 and a is less than n, b is greater than or equal to 0, b is less than m. If this cell is valid, then we, and what else, and the DFS of DFS, next X, next Y, and now we will match the next position, correct? And if it returns true, then we'll return true to its parent, correct? And at the end, if we did not find the character, then we replace this board with its original character and we return false, that from this call we did not find the character or the word that we were looking for. Will it work? And here we need to find the DFS. Here we already did the DFS. Let's see. Why is next cell valid? I think yeah, this way we write the lambda. Let's see. Okay, so let's try to submit this code. If you like this video, consider subscribing to the channel and see you in the next video.